Good day, grade 11th. Today we are going to look at some reverse operation of the midpoint and distance formula. So basically in grade 10, what you did was just the forward calculation where you were just looking for the midpoint of a line or calculate the length of a line. So now what happens is that you are going to be given the distance, and then you have to work backwards to find either an x or a y that is missing, as well as the midpoint, where you are now going to be working backwards. You are given the midpoint and then you have to find x or y. Okay, so we'll start with the midpoint one. The first example says find x and y if it is given that negative 2y is the midpoint of 4, 3 and x7. Remember, we just read it as 4, 3, not 4, 3. Okay. Right, so we know that the midpoint, so we write the midpoint and then you write it as you would normally calculate it if it wasn't given. So the midpoint of these two would have been 4 plus x divided by 2 and 3 plus 7 divided by 2. So that's what you did. But now because this is given, so that means this x is equals to that x, and then this y is equal to that y. That is what I mean here by equate the x's and the y's and solve for x or y. So depending on what is missing, then you just solve them. Okay, so that's what I did. I equated the x's. Negative 2 is equals to 4 plus x divided by 2, and then you cross multiply, and then you get negative 4 equals to 4 plus x multiply by 2. Remember, this is over 1, so negative 2 over 1. Then when you cross multiply, it will give you negative 4 equals to 4 plus x, and then you take 4 to the other side, and then it's negative 4 minus 4, which is equals to x, and then x is negative 8. Okay, and then y is equals to 3 plus 7 over 2. So here we are lucky that the variable just stands on its own, so y is going to be equals to 10 over 2, and then y is equals to 5. Right, so basically that is what you would be doing. Okay, second example. Now the distance, where you have to work backwards on the distance. Find k when it is given that the distance between point A and point B is 52 units. Okay, so again, you are given the distance, so you write what is given on the right hand side, and then this side you write the calculation that you would have done if this was not given. Okay, so I would have calculated this as 4 minus k squared plus negative 2 minus negative 8. Remember, minus negative 8 will make a plus. That's why I have a plus here. Okay, so we've got square root on both sides. So the first thing, for us to be able to solve for this k, we have to remove the square root. So how to remove square root? You square both sides. So that's what I did. And then 52 is equals to 4 minus k squared plus 6 squared, which is a simplification of that. And then remember, this means bracket times bracket la. Okay, so it's 16 minus 8k plus k squared plus 36, which is coming from that one, and then you solve the quadratic equation. So when you say 16 plus 36, we are like it's 52 minus that 52, it gives us a 0. So we are just left with that. So you factorize. Sometimes you will be left with a quadratic trinomial. That's why I said you factorize or just use a quadratic formula. So in this case, k is equals to 0 or k is equals to 8, and both of them qualify. Even if one of them was negative, both of them would still qualify. Please be careful there. Even if both of them were negative, they would both qualify. None of them is a not applicable. All of them qualify. Okay. Then the next concept that I want us to look at is the concept of equidistance. Now, points that are equidistant are points that are the same distance from a given point. So if I say CD are equidistant, C and D are equidistant from A, I mean the distance from A to C is the same as the distance from A to D. So the from is your middle point. So from is your middle point, and then it takes you to the one point and then the other point. Okay, so let's look at an example that makes use of that. Okay, A is equidistant from C and D. Okay, A is equidistant from C and D. Okay, so that means A is like that, and then we have, so A is like that, and then we have C and D. Okay, so that means AC is equals to AD. So that's what I did here. So again, you calculate the distance of AC like you'd normally do. -3 minus 7 squared plus P minus -1. That is why it is plus 1 here. And then you do AD. It's -3 minus 4. And then squared P minus -4 squared. And then again, because we've got the square root, we take square root on both sides to remove the root sign. Then we are left with -10 squared, and then again this is bracket squared, so it's bracket times bracket, which gives you that. And then please don't forget that. And then 49, and then again bracket squared, which gives you that. And then you bring everything to one side because it's quadratic, so 0. So everything else goes to the other side. So P, so this simplifies to 6P minus 36. And then we divide by 6 on both sides. So P minus 6 is equals to 0. So P is going to be equals to 6. All right, the last concept that we will look at today is the concept of collinear points. Now, points that are collinear are points that lie on the same line. The points that lie on the same line. So if I say A, B, C are collinear, I mean A, B, and C will be found on the same line. So that means the gradient, remember the gradient of this line, I can calculate using AC, or I can calculate using BC, or I can calculate it using AB. So the gradient is going to be the same at any given point. So gradient between A and B is the same as the gradient between B and C, and it is the same between A and C. So that is what I meant by this point. So we make use of that when we are required to find x and y. Okay, so that is what I did in example 4. Find x if A, B, and C are collinear. So you can see that C doesn't have an x value. So that is what we are looking for. So we find the gradient of AB. So AB, because both of them are given, and then you can then either do BC or you can do AC. So I did BC because remember, most equal sign can only work with between 2 points. Like when you solve an equation, you can only solve between 2 parts, not the 3 parts. Okay, so so you take 2 at a time like this, not all 3 of them at the same time. Okay, so I did the gradient. Remember, gradient is y2 minus y1 over x2 minus x1. And then if it is given the coordinates, then you will write ya minus yb. So then you substitute. So it is going to be 1 minus -2 over 1 minus 2, which is what I did here, which gives us 3 over -1. And then BC is then going to be 7 minus 1. 7 minus 1 and x minus 1. Okay, so it's you can also start this side and go that way, but I decided just to do it this way. Okay, then you cross multiply. So when you cross multiply, you will cross multiply because we've got a fraction this side and a fraction that side. We are trying to make it into one line. So 3x minus 1 will multiply 3. This is what I have, and then 6 times negative 1, and then that is what I have. And then you open the bracket, and then you solve, and then x comes out as negative 1. So basically, that is what is new in grade 11. So instead of just forward calculations, now we work backwards and use equations to solve for x and y. All right, so please do exercise 1, number 2, AB, number 3. Please make a correction on the textbook. D is supposed to be negative 3.6. And then number 4, do number 4 as well. And then hint yalapo iti show that they have the same midpoint. Thank you.